Good morning, this is Mrs. Doris. With picture day today, I thought we would put our warm-up on the video as well, and that way you can do it in case our class gets interrupted today with pictures. So, warm-up today. What I want you to do is to identify the error in each problem and then correct it. So, in our first problem, and it might help if we numbered it. All right, there we go. Number 1. What inequality represents the verbal statement? 5 less than Q is greater than or equal to 3.5. All right, the answer that has been given to you actually has 2 errors in it. See if you can find them. And number 2, what is the graph of inequality A is less than -5? Again, there's only one error here, so see if you can identify what that error would be. If you have any questions, please ask Mrs. Doris, and if you'd like me to check your work, please pause it, and I'll be happy to come do that. Okay, our lesson today is on solving inequalities, and we're going to combine lessons 3.2 and 3.3. We're going to use addition, subtraction, multiplication, and division to solve one-step inequalities. All right, and our whole reason for dealing with inequalities in Chapter 3 is because many times the relationship between quantities is not an equal one. Okay, the properties of inequalities are very, very similar to those of the properties of equality. Let A, B, and C be real numbers. If A is greater than B, then A plus C is greater than B plus C. If A is less than B, then A plus C is less than B plus C. And this property also holds true for greater than or equal to and less than or equal to. I want to show you a couple of examples, and we're going to make them simple. Suppose that we have 5 is greater than 4. All right, if I add the same thing to both sides, let's take 3. 5 plus 3 is greater than 4 plus 3. That looks way too much like a 7. All right, that's greater than. All right, let's simplify. 5 plus 3 is 8, is greater than 4 plus 3 is 7. This is a true statement, so it holds true. Let's take an example for our less than using maybe some negative numbers. All right, so just to make up an inequality, we'll take negative 2 is less than negative 1. We know that is true. Now let's add, let's say add 4 to both sides. All right, so we have negative 2 plus 4 is less than negative 1 plus 4. Negative 2 plus 4 is positive 2. Negative 1 plus 4 is positive 3. This is also a true statement. So please note that it doesn't matter what you add to both sides. If you start with a true inequality and you add the same thing to both sides, you will still have a true inequality. The same is true with the subtraction property of inequality. If we subtract the same number from both sides, then we still have a true inequality. A couple quick examples. Let's take negative 7 is greater than negative 10. We know that is a true statement. Let's subtract 1 from each side. Negative 7 minus 1 is greater than negative 10 minus 1. All right, negative 7 minus 1 is negative 8. Negative 10 minus 1 is negative 11. And you can see that we still have a true statement. All right. The same is true if we have a less than. So I'll just take 8 is less than 10. Suppose we subtract 10 from each side. If I take 8 minus 10 is less than 10 minus 10. 8 minus 10 is negative 2. 10 minus 10 is 0, and we still have a true statement. All right, let's do a little solving and graphing. Okay, our first equation is n minus 5 is less than negative 3. All right, we're going to undo the subtraction. Here's our variable. So what we have to undo is this part right here. And we undo that by adding 5 to each side. Okay, we're going to bring down our n. Our minus 5 and plus 5 is now equal to 0. And so n plus 0 is simply n. Bring down our inequality symbol. And negative 3 plus 5 is a positive 2. So we have n is less than positive 2. Now, you can see from the graph, please note, there is an open circle at the 2 because n is less than 2. It is not equal to 2. And then it's everything going to the left. All right? Also, when you circle your answer, be sure that you don't just circle 2 like you might have done on an equation. Your answer is actually the whole expression. N is less than 2. Using subtraction. In our next problem, here's our variable, y, so we have to get rid of the plus 12. And to do that, we're going to subtract 12 from each side of the inequality. Plus 12 and minus 12 cancels out. On the left side, we have negative 1 minus 12, or negative 1 plus negative 12, which would be negative 13, is greater than or equal to y. All right? When we go to graph that, it's very helpful if you'll turn it around. Turning it around means I want to put the variable on the left-hand side. That means flipping the symbol, the inequality symbol. So what was once greater than or equal to now is less than or equal to, and then negative 13. All right, so y is less than or equal to negative 13. Because of this line right here, we are going to make our circle closed. I'm going to make it bigger so you can see it. Because negative 13 is a solution to this inequality. And then it is everything to the left. Okay? All right, let's solve and graph these examples. All right, I have an addition problem, so I'm going to begin by subtracting 9 from each side of the inequality. Negative 31 minus 9 would be negative 40 is greater than x, since our plus 9 and minus 9 is equal to 0. Okay, I'm going to rewrite this to make it easier to graph. X, turn the symbol around. X is less than negative 40. Now, when we go to graph this one, you don't have to draw a big long number line. I like to make sure that we get at least 3 numbers on our number line. So I'm going to start at negative 40, since I know that's where my circle point is going to go. And let's see, 1 to the right would be negative 39. 1 to the left would be negative 41. Okay, when I go to graph this then, because it is less than and it is not equal to, I'm going to have a nice open circle at my negative 40. and it's all numbers less than that, so it's going to be everything in this direction, and we'll put an arrow to show that it continues going on. Okay? And here is my answer. On the next problem, x minus 21 is less than 6. We're going to use addition this time to undo the subtraction. Minus 21 plus 21 is 0, so cancels each other out. And I have x is less than 6 plus 21 is 27. Okay, so on my number line, I'm going to put 27, and to the right one would be 28, and to the left one, oops, start all over here, 26. Okay, so when we go to graph this one, we're going to have an open circle again, right there. All right, and then it is everything to the left. Okay, and I'm going to change this one just slightly so you can see what it would look like. If I had less than or equal to, then in my answer I have less than or equal to, and that would then tell me that I need to fill in my circle because 27 is less than or equal to 27, and it would therefore be a solution. The most common error that I see students make in all of this, I'm going to go ahead and circle my answer, is they'll end up solving the inequality correctly, but somehow in the translation they end up writing x equals 27. So don't let that be an error that you make. We are not dealing with equations in this lesson. We are dealing with inequalities. So you're going to have one of the 4 inequality symbols. Okay. All right, here we go. We have the multiplication property of inequality. It says that if A is greater than B, then if we take some number C, A times C is greater than B times C. And likewise, if A is less than B, A times C is less than B times C. Now, this is only true if C is greater than 0. Let's see what would happen if C is less than 0. All right, so we have an example. If C is negative 3 and 5 is greater than 4, what happens if I take 5 times negative 3? Is that greater than 4 times negative 3? Well, 5 times negative 3 is negative 15. 4 times negative 3 is negative 12, and we have a false statement. All right, because you can see on a number line, if I draw a number line right here, negative 15 is to the left. It's right here. And it's to the left of negative 12. So that tells me that negative 15 is less than negative 12. So that leads us to the following property. If C is less than 0, okay, then if we take an expression where A is greater than B, when we multiply by a negative number, we have to flip the inequality symbol. Let me get a different color here. Notice that here it's greater than, but if we multiply by a negative number, we flip the greater than and make it less than. Likewise, if we start with a number that is less than B and multiply by a negative number, we end up to make a true statement having to flip the inequality symbol and make it greater than. All right, and if I were taking notes, this is a major something that I would put into my notes as a reminder. All right, let's take a couple of examples. We'll take, let's see, A is greater than B. Let's take 0 is greater than -1. All right, and I'm going to let C be -2. So if I take -2 times 0 and -2 times -1, all right, and I see that -2 times 0 is 0, I'm going to have to flip my inequality symbol, and I probably should have done it up above, so I'm going to back up here. And flip it right here. Okay, 0 is going to be less than -2 times -1 is +2. This is a true statement, but notice that in order to make it true, I had to change my greater than symbol to a less than symbol. Let me take one more example, and we'll take one this time where A is less than B. So let's take 2 is less than 5. And I'm going to multiply both sides by the number -4. And these are just examples that I'm pulling out of the air. I'm going to go ahead and flip my symbol, and when I multiply the other side by -4, let's simplify and see what we get. 2 times -4 is -8. 5 times -4 is -20. And -8 is greater than -20. So we have a true statement. On a number line, if we were graphing this, -20 would be down here somewhere. If this is our 0, -8 might be about here. And so since -8 is to the right of -20, then -8 is greater than -20. So don't forget to flip your inequality symbol when you multiply by a negative number. All right, the division property is the same way, and you're going to find that what is true for multiplication is also true for division. So let's finish this. If A is greater than B, then, and notice here we're dealing with a number C that's greater than 0. A divided by C will be greater than B divided by C. All right, an example, let's take 20 is greater than 10. And we're going to divide both sides by a +5. 20 divided by 5 is 4. 10 divided by 5 is 2. And we see that 4 is greater than 2. That is a true statement. All right, let's take A is less than B. All right, if we divide by a positive number C, then we should get a true statement. And let's take something different. Let's take, let's say 35 is less than 50. All right, we're going to divide both sides by a +5. And you'll see 35 divided by 5 is 7. 50 divided by 5 is 10, and again, we have a true statement, keeping our inequality symbol the same. However, when C is less than 0, we have a different story, just as in multiplication. Looking at our example, if we take 15 is greater than 10, and we divide by -5, 15 divided by -5 is -3. 10 divided by -5 is -2. And in order for this to be a true statement, we have to flip our inequality symbol around. Negative 3 lies to the left of negative 2 on a number line. As in, here's 0, negative 1, negative 2, negative 3. And you can see negative 3 is to the left of negative 2, meaning it is smaller. Okay, so this leads us to the division property of inequality. And the division property of inequality says when we are dealing with a divisor that is less than 0, if A is greater than B, then A divided by C is going to be less than, notice I've changed the symbol, than B over C. And likewise, if A is less than B, then A divided by C, I've got to flip the symbol, to greater is going to be greater than B divided by C. And of course these properties also hold true for greater than or equal to and less than or equal to. So in summary, if you multiply or divide each side of an inequality by a negative number, you need to reverse or flip the inequality symbol. Okay, a couple of examples. One with a positive number and one with a negative number. If we have x divided by 5 is greater than 2 and we multiply both sides by 5, our 5's cancel out and we get x is greater than 10. That is a true statement. So when we graph that, we have an open circle at x is greater than 10, and it's all numbers to the right. So fill in our line and put our arrow on to show that it continues going. All right, if we multiply by a negative number, in this next case, here we are dividing by, multiplying by a negative 5 in order to get rid of the denominator of negative 5. Our negative 5's cancel out, leaving us with the x, which we bring down here. But notice what was greater than now has to be flipped to make it less than. All right, and so we're applying what we know to be true with simple numbers to algebraic expressions where we have a variable in them. And then of course 2 times negative 5 is negative 10. So to graph our expression, open circle at negative 10, since negative 10 is not a solution, and then an arrow to the left. All right. Let's try these now from scratch. We have n divided by 13, so I want to undo the division and multiply each side by 13. My 13's cancel out and leave me with n on the left-hand side. On the right-hand side, negative 8 times 13 would be negative 78. All right, since I multiplied both sides by a positive number, notice it's a positive 13, my inequality symbol of less than stays the same. It does not matter what this number is. So even though there's a negative 6 there, the only thing that matters is what you are doing to both sides. And since we're multiplying by a positive number, our inequality symbol stays the same. In our other example, however, we have y divided by a negative 3. So we want to multiply both sides here by negative 3 in order to lose the denominator. Because we're multiplying by a negative number, we need to flip the inequality symbol from greater than to less than, and then simplify the right side. 15 times negative 3 would be negative 45. Okay? All right, let's graph each one of these just so you can see what the graphs would look like. And again, they don't need to be super long. I definitely want negative 78 on my graph. This would be negative 77. This would be negative 79. I'm going to have an open circle here and an arrow to the left. Okay? And on this one, I'm going to change this one just to show you the difference in graphs. I'm going to make it greater than or equal to, and therefore when I flip my symbol it now becomes less than or equal to. And when I draw my number line, again I definitely want to put negative 45 on my number line. Negative 44 would be to the right and negative 46 to the left. So when I graph this one, now at negative 45, because of the equal part of the sign, I'm going to fill in the dot because y could be equal to negative 45. And then we have an arrow to the left, including all numbers below negative 45. Okay, same is true with division, and you can take a look at these examples. Notice that when we divide by a positive number, again, this number here does not matter. What matters is what you're dividing by. The inequality symbol stays the same. It's greater than and it stays greater than. When we graph our answer, x is greater than negative 4, it's going to be everything in this direction. Okay? But when we divide by a negative number, as we do here, when we have a coefficient of negative 4, we want to get rid of that. Notice how our less than or equal to symbol changed into greater than or equal to. All right, so when we graph that, we're going to have a closed dot at negative 3 and an arrow to the right. All right, couple from scratch. Here I have 14 times x is greater than 70, so I'm going to divide by 14 to undo. All right, 14 over 14 is equal to 1. 1 times x is simply x. 70 divided by 14 is 5. When I graph, I'm going to put 5 here, 6 will be to the right, 4 to the left, and I will have an open circle at the 5 since it's not equal to 5, and x is all numbers greater than. All right. In my next problem, negative 5 times x is less than 75. I'm going to divide both sides by negative 5. And I'm dividing by a negative number, so I have to always keep that in my head. When I multiply or divide by a negative number, I have to take this inequality symbol and turn it around. So I'm going to flip it in the opposite direction. What was less than is now greater than. And 75 divided by negative 5 is negative 15. So I have x is greater than negative 15. And when I go to graph, here's negative 15. And I ask you to do this. Always put at least 3 numbers on your number line. So I like to put the number that I'm going to put my circle or my closed circle at, and then a couple of numbers on either side. All right, so x is greater than 15. I'm going to put an open circle since it's not equal to, And then my arrow goes to the right to indicate all numbers greater than negative 15. All right, that finishes our lesson. I hope I didn't bore you too much there. You have some exercises to try on page 174 and page 181. If you have any questions, please ask. Just remember, if you multiply or divide by a negative number, what do? Flip the inequality symbol. All right, thanks, and I'll see you in class.